Chapter 8. Consider a modern air conditioner using R working in heat pump mode. As shown in this picture, it has a COP of 4. Heat pump COP with 10 kilowatt of power input. The cold side is buried underground where it is 8 degrees centigrade TL, and the hot side is a house kept at 21 degrees centigrade. For simplicity, assume that the cycle has a high temperature of 15 degrees centigrade T, it is not TH, it's a T. Excuse me, it is soil. Assume that the cycle has a high temperature at T low temperature degrees centigrade. Because section, we would like to know where entropy is generation associated with the heat pump, assuming a steady state operation. Where entropy is generated. Now, at first, let us look first at the heat pump itself. It is a control volume. Heat pump. For the heat pump, we have a Q dot H to the Q dot L. W dot to heat pump. We know from the heat pump that COP is Q dot H on W dot our input. Q dot H can be calculated or can be expressed as multiply W dot with knowing the COP and the our input. We can calculate Q dot H and is 40 kilowatts. We know also W dot equals to Q dot H. Q dot L 10 equals to Q dot L equals to 30 kilowatt. In this case, for the entropy change for the heat, the reversible steady state, we have this relation for S dot Q dot H plus S dot generation of heat pump. S dot generation of heat pump can be calculated as is T high minus 10 on T this is a 30. Can be calculated as is watt on as the first control volume pump. Now consider for the underground reservoir. We have a QL here, 8 degrees centigrade, 2T low, S dot Q dot L, 2T low, Q dot L to TL at first, the first temperature coming from this surrounding and from this surrounding to 10 degrees minus Q dot L on T low plus S generation for the underground. Can be calculated and consider now another control value 2, where TH is 21, T high is 50 degrees centigrade. At first Q goes to so S dot generation, S dot equals to Q dot H on at first T high, Q dot H on TH plus S dot generation of control value 2. S generation of control value 2 is calculated as T high 50 degree, and on Kelvin. There is no another control value, so the total entropy generation is the V1 is generation, CV2 is generation, HP. We can also write this expression as Q dot L on T log minus Q dot L on T L plus Q dot H on TH minus Q dot H on T high plus Q dot H T high minus Q dot L T low for the heat pump. With simplicity, we have only as power generation total Q dot H TH minus Q dot L on TLS.